So, hello guys, I am Fresado, fourth year computer engineering from Bicol University, Pulangi, belonging to the section 4B, and I am here to discuss my activity output in laboratory activity 10, which is all about C transform. So, the objectives for this activity is to compute and visualize the C transform of a given discrete time signal. So here we are tasked to compute for the C transform of three sequences by using SymPy in Python and NumPy and Matplotlib to plot the graph. So these three functions actually are the unit impulse, the unit step, and the exponential sequence. So here we define our symbols in the code. Just first we call the libraries, then NumPy, Matplotlib, Asplot, and SciPy for the signal. And now we first define the sample knowledge. Negative 5 to 15. And now the signals. We define them. And then the codes we also define. And after that, we use sci-fi to de- define a system where we create a digital transfer function which shows the step response as shown at the plot over time, as you can see here. So the range is from negative 5 to 15. Same for the unit impulse, the step, exponential, and the response signal. In this activity, we are tasked to explore also the inversely transform. So we need to solve using Python for that. And also analyze the stability, which is the location of the poles in the CP. So in this test piece, we had a pole at 0.5. So the idea here is a system is stable if a point is inside the unit circle. So if it's out the unit circle, so we can say that it's unstable. So this is the region of convergence, which defines the range of C values where the transform exists. So this is essential for ensuring that our models are valid. We answer now the guide questions. As you can see here, this is the code and this is my output. Similar to the plot. So we were asked if the system is stable. Yes. So the system is stable. So what does it mean for the poles to be inside the unit circle in the CP? So as I said earlier, the system is stable if the poles are inside the unit circle. So if it was outside, so it will grow infinitely. So we have an unstable system that happens. So the region of convergence, we were tasked to discuss the ROC. So this region of convergence, as I said earlier, defines the causality and the stability of the system. In which I said if it's inside the unit circle or the ROC, it is stable. So if it's not, the signal would grow infinitely and will be unstable. So we were also asked to discuss the application. So as you can see, this is the C transform. Using it has numerous real-world applications, especially in engineering and technology, where it can be used as a filter design to transform different equations for easier analysis. And it is vital to, especially in this subject, to analyze the frequency responses in image and audio data, and also in control systems to define the stability of the controllers used in automation in robotics. So that is all. Thank you.